Section 1.6 is about midpoint and distance when we're looking at the coordinate plane. So if you have 2 points, and we tend to write our points as actual points with an x and a y in here, but because we have 2 different points, we're going to say that this is the first x, and this is the first y, and this is the second x and the second y. So the little 1s and 2s are just telling us that this is point number 1 and that's point number 2. We can find the distance between these 2 points using either the distance formula or what we practiced yesterday, the Pythagorean theorem. So the distance formula is a pretty long and big formula, and we tend to only use this if we are given 2 points. And the distance formula says that the distance between 2 points is the square root, and make it a big square root, of the x values in my points subtracted from each other and squared. And then we add that to the y values in my points subtracted from each other and squared. And this comes from the distance formula. We square 2 things, then we take the square root to find the hypotenuse. But this is only to use if we have 2 points. Like I tell you, one point is at 3, -2, and the other point is at 6, 8. Then you would use the distance formula. But we can use what we learned yesterday with Pythagorean theorem and use that if we are given a graph or a picture, just like we did yesterday. And remember, the Pythagorean theorem is this. But if we were solving for a hypotenuse, we know that we end up square rooting both sides. So it doesn't really matter which one you remember, a squared plus b squared equals c squared, or that c equals the square root of a squared plus b squared, because they're kind of the same thing. So these are the 2 types of problems you're going to get with the distance formula. It's going to give you 2 points, and then it's going to give you a graph. Let's do the graph picture one, because we know how to do that. If I want to find this distance right here from A to B, just like we did yesterday with our power lines, we need to draw a nice triangle here, and we need to find the distance between those 2 points. So on a graph, it's pretty easy to find the distance because all we have to do is count. So if I count from -5 all the way over to 3, that's 8 spaces. And if I count from 1 to 6, that's 5 spaces. So then we can use Pythagorean theorem to find that c. So let's do 5 squared plus 8 squared equals our c squared that we don't know. 5 squared is 25. 8 squared is 64. And if we add these together, we end up with 89. And this isn't a perfect square, so when we plug it in, we'll end up getting a decimal, which is okay. And we'll round it to the first number after, so we get about 9.4. That's the distance between point A and B. Now, this one that we skipped is exactly the same problem, so we should expect to get the same answer. Point A is at over 3 up 1, and then this one is at backwards 5 up 6. Let's change this. A should be at, I don't know why that's not working. A should be at, let's try this again. Should be at 3, 1. So if we find the distance between these 2, we're going to use the distance formula because we are given 2 points. So the distance equals the square root of, we're going to take our x values and subtract them. So our second x value is -5. And we want to subtract our first x value, which is 3, square it, and then add our y values. So our second y value is 6. Minus our first y value, which is 1, and square it. So then we got to do a little bit of algebra here. If you do -5 minus 3 more, you get -8 squared. If you do 6 minus 1, you get 5 squared. And negative 8 squared is 64. 5 squared is 25. And these numbers should start to look familiar. We saw those exact same numbers here. And when we add them up, we still get 89. And then we got to take the square root of it, just like we did here. So you still end up with the distance of 9.4. So it doesn't matter which one you use. Obviously, the Pythagorean theorem is a little easier, but sometimes if you're not given a graph, you have to use the distance formula. So now that we've talked about distance between 2 points, let's talk about a midpoint. A midpoint is a point in the middle of 2 other points, and it's a brand spanking new point. So if I take a look at this line right here, it's really easy to see on this graph that directly in the middle is this right here. So if we were to stop and think about these points that we have here, this first point A is at 1, 1, and our other endpoint B is at 5, 3. Our midpoint, this guy right here that's right in the middle, is over 3 and up 2. So if we take a look at this, it's kind of cool to see how we get these numbers. Like if we look, like what is right in between 1 and 5? Well, 3 is directly in between 1 and 5, and that's where this part of our point comes from. And we can do the same thing here. What's directly in between 1 and 3? Well, it's 2, and that's where this comes from. It's what's right in the middle of our 2 points. So the other way that we mathematically describe this is called average. The average of 1 and 5 is 3, and the average of 1 and 3 is 2. And if you remember how to find the average, you add up the 2 numbers you're trying to find, and you divide by 2, because you have 2 numbers. And if you do 1 plus 5, you'd get 6. Divide by 2, and that's where our 3 comes from. And that's what the midpoint formula looks like. So midpoint formula is a point with a comma in between, but it's a big point. So you're going to take your 2 x's and you're going to add them together, and then you're going to divide by 2 because you want to find their averages, just like we did up here. We took our 2 x's, 1 and 5, we added them up, and we divided by 2. And then you do the same thing with the y's. So the midpoint formula and the distance formula are very, very easy to get mixed up, so make sure you write them both in your vocabulary so you have them on a test or a quiz. So if we want to do a problem, it'll tell us that we need to find the midpoint of segment MN, where M is at 1, 3, and N is at negative 4, 6. So I could draw this out. If we do a rough sketch, M is over 1, up 3, and N is back 4, up 6. I want to know what's right in the middle here. So in order to do that, I need to take my x's and add them up, and then find the average of my x's. And then I got to do the same thing with my y's. Take my 2 y's, add them up, and cut it in half to see what's directly in between. So 1 plus a negative 4 gives me a negative 3. 3 plus 6 gives me 9. And you can leave it like this, or we could convert it to decimals if you really wanted to. So this is like negative 1.5, comma 4.5. And I always think it's a good idea to make sure that your answer makes sense. So I drew this little rough sketch on here, but back 1.5 and up 4.5 would make sense with where I have that dot. So now another type of problem you'll get is a little different. It's going to tell you what the midpoint is. So let's say that we have MF. So MF. And it tells us that X is the midpoint. So X is smack dab in the center. M is at 2, 2, and X is at 4, negative 3. We need to find F. So we can do this a couple different ways. We can use the formula. So the formula says that the midpoint, which is 4, negative 3, equals, need an equal sign there, my first x plus my second x, cut in half, and my first x plus my second y, cut in half. So remember that because this isn't a point, that's saying that this part has to equal this part, because those are your x's, and this part has to equal this part. So you can set up two different equations if you want. I can say I know 4 has to equal 2 plus something, all divided by 2, and solve this. So the opposite of division is multiplication. And then we'll subtract 2. So we get that 6 is my x. And then our other one can be this equation, that negative 3 has to equal 2 plus something divided by 2. So the steps are the same, just with different numbers. We'll multiply by 2 to get rid of that. And we'll subtract 2 to get y alone. So the y part of this has to be a negative 8 in order for this to work. Or instead of doing all that work, we can stop and think about what we have here. Remember, your midpoint is directly in the middle. So if you just look at your x's, remember we don't know this yet. We don't know that it's 6, negative 8. Let's write it down somewhere. If you just look at your x's, how much space did you move from point M to point X? Well, you added 2. And because you have to do the exact same thing on the other side for your x's, this x is going to be 2 plus 4, or 6. And you can do the same thing with the y's. How do you go from 2 to negative 3? Well, I'd have to subtract 5. So now I got to take negative 3 and subtract 5 more, and there's where my negative 8 comes from. I personally like to do this way more than all this other work. But if this isn't making sense to you, you can always use the formula. But either way, we found out that that other point has to be 6, negative 8 if we want x to be the midpoint. So now you have several things to do while I'm not here. The first thing that I want you to do is the worksheet. It's 1.6 problem solving. I think there's like 7 problems on it, but this is due at the end of the hour. So I want whatever you have done turned into the sub. And then the other thing you can work on is your IXL homework. And there's a couple of those. It's in the geometry section. And it is B.4, B.7, and B.8. And remember, all of this is on Google Classroom for you to look at also, except the worksheet. So if you had any questions on this, make sure you put a star next to it or write your question out, and I can answer them on Thursday when I get back. Hope you guys had a good day.